Okay, so this is chapter 3, number 9. Sorry, got some hair on my phone. Alright, so it says, write an expression using sigma notation that represents the sum of the areas of the rectangles shown for the function at the right. Note, the rectangles have equal widths. Alright, so I've already written out the equation that you're going to be using for this. So let's take a look at our rectangles here. What do we notice? It's left endpoint rectangles. Left endpoint rectangles means we can use the left endpoint equation for the Riemann sums, which is the summation, which is the sigma, n minus 1, k is equal to 0, delta x, which is just change in x, f of a plus delta x times k. That's our equation right there. So you might wonder what delta x is equal to. Delta x is equal to b minus a over n. So, alright, what is n equal to? N is equal to the number of rectangles. That means n is equal to 6, right? And then what is b and a equal to? B and a are your intercepts. So your stopping intercepts right here. So this right here is a, this right here is b. Alright, given that knowledge, let's see what we can do. Alright, so remember, I wrote out our equations here for the left endpoint rectangles, alright? And then all I did was I just plugged in all the numbers. So remember, 6 is the number, 6 is equal to n, right? So 6 minus 1 gives me 5. Our starting point is 0, right? So start to stop, starts at 0, ends at 5. Delta x, here's what we're going to do. We're going to plug in b, which is 1, minus a, which is negative 1. That gives us 2 over 6, which is equal to 1/3. So delta x is equal to 1/3. Delta x, 1/3, times g, in this case, because we have a, I believe is a g? Yeah. G, and then we have negative 1, because that's our a, plus delta x, 1/3, I. So what's interesting is that you notice that I've changed up my variables here. And I just did that to show you that you can put whatever variables you want here, because the variables don't change anything in this equation. Here there's an f here, there's an I here, there's a g here. Over here we have a k and we have an f, right? Well, you only want to put the variables that you want to put in, but it's good to stay consistent. But I just wanted to show that you can change the variables and the variables don't do anything to the actual answer. So that right there is our answer. That was number 9 in chapter 3, and I hope that helped. Thank you for watching.